Now we're going to do a few examples of specific sequences and see if we can figure out whether or not they converge. Starting with part A of example 3, just for your reference, this is on page 81 of the workbook. Okay, and they're asking us in this question, for each of the following, determine whether the sequence converges or diverges, and if it converges, to find the limit. Okay, now just to remind you of what a sequence is all about again, remember that this bracket notation is just representing a big list of numbers. So we're kind of thinking of starting this sequence out with n equals 1 and just continuing to n equals 2, n equals 3, and so on. So this sequence is really just a big list of numbers. You could go to your calculator and actually figure out numbers for these, figure out what their decimal approximations are, and we're simply being asked, does the sequence approach something? Does it converge? Okay, mathematically, that's just asking us to calculate a limit. Okay, and in a lot of these sequences, you'll notice that it starts out in the form infinity over infinity. Okay, as n gets really, really big and approaches infinity, the numerator and the denominator both are approaching infinity. Okay, which means that the tool that we want to use to take this limit is L'Hopital's rule. Okay, so as we did before, we need to take the derivative of the top and the bottom of our fraction. Okay, the derivative of the natural log of n is 1 over n, and the derivative of n is 1. And so our new limit looks like the limit as n goes to infinity of 1 over n over 1. And then we notice that 1 over n over 1 is really just the same as 1 over n. If you divide a number by 1, you get that same number. So this is really the limit that we're looking at. Okay, now it comes down to what happens to the fraction 1 over n as n gets large. 1 is just a constant in the top, and in the denominator, n is getting really, really big. It's going off to infinity. So we've got a constant over something that's really, really big. That tells us that we should be approaching 0. So we've just shown that this sequence converges to 0. Okay, and just a word about notation here. Okay, in this part of the course, we start talking about sequences in series. We tend to emphasize notation more than we have earlier in the course, so be aware that when you do a calculation like this, it's important to write these limit signs. Okay, every time you're taking a limit, that's part of the notation that lets us know that we're talking about sequence convergence, so it is necessary to write those each time you do that calculation.